Live. We're live. Okay. Thank you for your patience. Thank you for your patience. So, hello everybody. Welcome to Comp 2150 Object Orientation. Today we are going to be spending some time looking at basic OO concepts. And I'm going to be direct and say that this is probably going to be some of a review from Comp 1020, going back at least a year in your degree program. What I want you to be able to do based on what we're doing in class today is primarily about communication. The terminology that I'm going to be using to describe some of these concepts is probably new to you outside of what you did already in Comp 1020. So you may have done the mechanical work of programming these ideas before, but I'm going to be using new terminology to describe some of the ideas that we're doing with those basic things in OO. So what I want to do is spend a little bit of time going over some of the terminology that is the technical terminology to describe some of the ideas related to OO that you may or may not already be familiar with. I'll show you some examples in Java, and I want to show you a counter example in C. So how OO as a concept helps enforce some of the ideas that we have related to things like abstract data types. So, the earliest approach to doing anything that looked like OO was to use something that is called a record. A record is a named definition of fields, attributes, or properties. These three words, fields, attributes, or properties, to me are all synonyms. They all mean the same thing. A record is a named thing that contains all of those. You have used this idea before, minimally in Comp 2160. You might have seen it in Comp 1012 if you did 1012. You probably never thought about it this way in Comp 1010 or 1020, but in Comp 2160, certainly, this is also known as a struct. This is what a struct is. A struct is a record type. The other half of this, records are a named definition of fields, attributes, or properties. An instance of a record, so an actual copy of this record type, can have a state. And the state of a record is the value that the variables that are defined in that structure have at any point in time in execution of a program. I would like to give you an example of building a record in Java. To do that, I would like you to help me out a little bit. I have a thing here. I'm going to walk around. I got a thing. I'll let you all see what my thing is. This sounds really weird, especially if you're like actually watching this live stream later and you can't see what I'm showing. I've got a Game Boy. I've got a Game Boy Color. This is my Game Boy. I've had this since I was about 9 years old. This is my Game Boy. I would like to take this. Also, I have this little cartridge in here called an Easy Flash. And it lets me put an SD card, a micro SD card in, with a bunch of ROMs. There, I'm admitting to stealing video games. This is my Game Boy. I would like us to build a record that represents this Game Boy in Java. Before we even start writing code, I want you to help me with this. Part of me building a record is trying to identify what kinds of things in this object can have a state. What things can have a state? The field's properties are attributes. These are named variables that will represent the state of this object at any given time. So please help me out. What kinds of things can have a state in this object? Type it in. Oh, yeah, battery. Yes, a battery. Yeah, okay, sure, a battery. That's terrible. That also just doesn't do anything. Oh, there we go. There's my Game Boy. So what kinds of things can have a state? The battery, the memory, the model number, the games, the screens, the display, the buttons, pixels on or off. Okay, these are all really great. This, actually, I don't even know if the batteries work, but this is a modded Game Boy Color, and it has a backlit display. That's not stock.
How do you put that in?
You gotta rip it apart, and you gotta buy, it's a special display kit that you can buy that just replaces the stock display. The battery is dry, it says. All right, so let's take some of these properties and put them into a Java record. I'm going to put this to the side of my screen here. I'm going to keep it up. I'm going to open up my editor here. And I would like to start building this record in Java. I'm just going to switch this back to my laptop here. I'm going to make a new class to represent what this thing is. So I'm going to call it gameboy.java. I'm going to build a record that represents some of the things that we've identified here as a state. I'm going to start with buttons. I think these are great things to have state in our record type that represents my object. What's a good type, a good primitive type, do you think, to represent these buttons? Boolean. Okay, good. I like that. Boolean. And I'm going to actually represent separate buttons here. A button, Boolean, B button, Boolean start, Boolean select. OK. I'm going to leave the D-pad out for now. The other things that I can see here that I think are important are the display. That's something that can have a state in this object. I'm going to use a byte array to represent that. So this is just an array of bytes. The Game Boy Color has color pixels, so we'll just call them bytes. We'll just say we can pack each color into a byte. The other thing that I see here is memory. So let's put that in, byte memory. Each byte here represents a single byte in the main memory of my Game Boy type. OK, cool. I have now built a record in Java. This is a named collection of attributes or properties that represent the state of a thing. I can use this type in Java by still using that new keyword to construct this object. So I can say final Game Boy GB is equal to new Game Boy. I can still create an instance of this record in my Java program. And I can do things like modify the state of it. So I can say that a button is equal to true. I can change these properties of this record in my Java program. I now have a record in Java that represents my thing, my object. Great. Let's take this record and start to change it into something that represents a little bit more of what we're trying to do. We've got a class in Java. We've literally used that class keyword, but all we've really done is build something that looks a lot like the structs that we had in C. We omitted specific keywords from the definition of our record in Java. We didn't put access modifiers on any of these properties. We just left them blank because that's kind of what it looks like in C. But classes and object-oriented programming languages can have access modifiers. Classes can have private fields or protected fields or public fields. Classes can also have behavior that's bundled with the data. So not just the set of data, but actually having behavior that's bundled with it. Classes can be related to each other genetically. We have this idea of inheritance. We can have a class having a subclass and a superclass. These are things that we cannot have in basic primitive record types. For the record, pun sort of intended, for the record, there is an actual type called record in Java 17+. So in very modern versions of Java, there's actually a record type. The record type itself is what's called an immutable object. And what that means is that once you have constructed a copy of this, you can't change anything about it. So it's going to give you something that's effectively read-only. This is not the same as what we've done here, but just for the record, for what it's worth. Records in languages like C don't have any of these things. So we don't have the ability to do anything like having private access to fields. We don't have anything like behavior that we can bundle in with the data. We don't have anything like having relationships between different structures. A class now is a named definition of fields, attributes, and properties. All structures can be a class, but not all classes can be a structure. The important distinction between a record and a class is that a class is a structure that has behavior bundled in with it. That's the defining characteristic that changes a structure or a record into a class. Similar to records and similar to structs, this is kind of a template that's used to tell your programming language and to tell your machine and to tell your interpreter what it should look like in memory for this thing that you're trying to create. An instance of a class is a physical thing. So this is something that's in memory. We have an address. There are actual bytes in memory somewhere that contain, so I'm using this word contain abstractly, that contain the values that correspond to the properties that we have defined in the structure itself. This is something that can have a state. We've got literal memory, we have addresses, we can change the values that we have in memory for the instance of that class. So in C, this is us declaring a stack variable that's a struct. In Java, this is us using that new keyword. We're asking for memory to be allocated for our program that matches the structure that we've defined in the class definition or in the structure or record definition. Classes themselves, so the thing, the template itself, can have class variables and methods on top of instance variables and methods. So variables and values that are part of the class, the entire group of things, as opposed to each individual instance of this class that we've defined. In Java, this is using that static modifier. This is a method or a variable that is going to be attached to the class name itself as opposed to an instance of that class. Let's change our record into an actual class in Java. So I'm going to switch back to VS Code here. And I'm going to make this record into a class. I'm going to change this into a class as opposed to just a plain old struct. First, I'm going to apply modifiers, access modifiers. I want the state of this thing to be internal to this object, and I don't want anyone else to be able to access or make changes to it. So I'm going to use the private access modifier here. When I save this, my compiler is now telling me that I no longer have the ability to just access properties of this record because I have been forbidden from doing that by using this access modifier. I'm going to make a change to this class, or to this record, to this thing that is becoming a class, to bundle some behavior with the data. The behavior that I want to bundle with this is I want to be able to change the state of the fields, the attributes, the properties that I have in this struct. So I'm going to declare a new method, public void press A. Press A. This method is going to change the state of one of the properties that I have in this class. I'm going to add another method to this. I'm going to change the state that an object that is an instance of this class has as my program is executing using this method. And I'll add two more here. If I were to keep going with this, because it's thrilling, if I were to keep going with this, I would add additional methods here. I would add methods to change the state of memory. I would add methods that would allow me to give addresses in this memory and make changes to those. I would have a method that would allow me to access the state of the display. I wouldn't want to change the state of the display, but I would want to be able to access it so that I could display it on my screen, on my computer screen, something like that. I can call these methods now in this class that I've got that lets me change the state of this class. Okay. Exciting. This is really thrilling. I know, this is really, really thrilling. I have taken my structure, my record type, and I have changed this into a class. I have access modifiers, and I have behavior that's bundled in with the data. I started with just data, named data. Now I've got access modifiers, and now I've got behavior that's bundled with it. Yeah.
So pretty much we could think of records as like the variables are kind of public. You can just change whereas classes, you need sort of getters and setters to modify the variables.
Okay, so that's a great question. I'm just going to repeat it. So the question is the difference between a class and a record just that a class has all private as opposed to a record that has all public? Is that true?
Yeah.
Okay. That's part of it. This is still a class. The defining characteristic here, the really important defining characteristic, is that I'm bundling behavior with my data. So if I left these as all public, it's still a class as long as there's behavior modification that's bundled in with that name.
So more with classes, you want to be modifying your variables
Yes.
in state using these methods.
Yes.
Rather than just directly select equals true.
That's right.
Okay.
The goal here, ultimately, is that other classes and objects that are using this one shouldn't know anything about how it's implemented. They shouldn't know or care anything about how it's implemented. They should be able to ask it to make changes to itself, and it will make those changes to itself. So state and then ways to change its state, but the caller doesn't know or care how that internal state is represented.
Okay.
Good? Good. Okay, so an abstract data type. An abstract data type is a set of operations that you can apply to data. You can think of this as an interface for data. I don't like to use the word interface here quite yet because, yes, I know that you saw this word in Comp 2160, and I know that part of what this is to you in terms of working with data structures is taking the function definitions out and putting them into a header file. But an abstract data type really doesn't have anything to do with programming at all. I have this great deck of cards. It's really great. I'm going to shuffle it up. I hope that the sound is coming through on audio here. I'm a stack. I am a stack. There are two operations that you can do to a stack. What are the two operations? Just shout it out. Push, pop. Okay, push and pop. Here. What are you going to do? You're going to push to the stack. Push to the stack. Okay. Okay, now push to the stack again. Okay. Okay. What else can you do from the stack? Okay. Here's the last thing that you put on. Okay, push to the stack again. Okay. I'm trying to blindly see behind me here. Okay, push to the stack again. Push again. Okay, now pop from the stack. Do you know how I'm actually keeping track of these cards behind my back?
I can guess.
Would you surprise, it's actually a stack of cards. Okay, yeah, it's a stack of cards. Okay, yes. I'll take them back now. Thank you for playing along. You did this with a list before, right? Yes? Yeah, you made a list. Why didn't you just make a stack? Because you can't, right? You can't. My abstract data type here is operations that you can apply to data. I was holding data. There were operations that you could apply to me when I was holding the data. You could give data to me and get data from me. You didn't need to know or care about how I was actually doing it. You didn't care. You could guess. You could make a very good educated guess about what I was doing, but you didn't need to know anything about what I was actually doing. Implementing ADTs is something that you've done a lot. You just spent like an entire term implementing ADTs in Java and a little bit of implementing ADTs in C. You spent a lot of time implementing things like, it was 2-3 trees, right? Yeah, 2-3 trees. You spent a lot of time doing that. A 2-3 tree is a tree. It is a tree ADT. Yes, an implementation of a tree ADT. C is not an object-oriented programming language. I don't think that there's any argument about that. But we can implement ADTs in C. You had to do this. We can do it. Let's see what's wrong with implementing an ADT in C, or what can go wrong with implementing an ADT in C. I have made this really nice stack. Is that okay at the back? Can you see that okay? Good. Sure. Is that better? Okay, good. There's my stack. Maybe you've never seen pragma once before. This is a include guard. This is the same as if, def, and define. It's just all in one. But the rest of it you've definitely seen before. I have an interface to a stack. You don't know how that's implemented. You don't know how that's implemented. I have a type def that lets me forward declare my structure. I have a constructor make stack function. I've got a print stack function, and I've got a push and a pop. That is my stack implementation interface. That's my interface for my stack. I'm going to reveal to you my bad C programming skills. And here, this is my implementation of a stack. I've got a size that is the amount that I can put into the stack. I've got where we currently are in the stack, and then I've got an array that is the values that we have currently pushed onto this stack. I'm dynamically allocating the array of size, whatever it is that I'm passing in here. And I'm setting my top to 0. It's empty. I've got a print stack function that will go through and use the properties that I've internally defined in this stack and print stuff out up to the top of the stack, but it won't go beyond the top of the stack. And I've got push and pop operations here. OK, great. Excellent. We have a stack in C. Here's a main function that I've written. I declare a pointer to a stack. I call my initializer function. You thought you were done with C. You thought you were all done with C. Got an initializer function. It's a pointer to a stack. I'm asking for a stack that has 5 things in it. I want to be able to put 5 things on my stack. I push a couple things to my stack. I pop something off of my stack, and then I print the state of my stack. I'm going to compile and run this code. Whoops, unused variable. There, I compiled my stack here. I'm going to run my main function. Looks great. It really looks great. That's really, really small. There, now it looks great. Now it looks excellent. It works. OK, I'm going to uncomment that stuff. Here, I'm declaring a pointer to an integer. And then I'm casting my pointer to stack to a pointer to integer. And then I start changing stuff. Do you have any predictions about what's going to happen here? Any ideas? Segfault? That would be a great guess. That really would be a good guess. But you're actually wrong. Yeah. Don't be ashamed that you're wrong in this case, because it's totally okay. Let's try this out. I'm going to go back to my terminal here. I'm going to cat my makefile, just so you can see what's in here. I turned on all the warnings, everything. Like, this is more than you've probably seen before. I turned them all on. I don't get any warnings. It must be good, right? This behaves a little differently on a Mac. On a Mac, all the values are 0 instead of just like random numbers, but the output is approximately the same. In C, I can absolutely implement an ADT in C. I don't think that there's any, I don't think there's an argument here that says, no, I can't implement an ADT in C. The problem with languages like C is that it's helping you aim that gun. The implementation is hidden from me. If all I gave to you was stack.o, you couldn't see how that was implemented. You couldn't go and look in it. Yeah, you could decompile it and you could try to like figure out what the program's code originally was. But you wouldn't necessarily be able to see the physical implementation of this thing. Even though you can't see the implementation of this thing, you can still make changes to it. And I've demonstrated that here. If I take this pointer and I cast it to another type, which doesn't emit any warnings at all, it just works. And I can start making changes to these internal properties of your data structure. When I call something private in Java, I can't. There's just no mechanism for me to do this. I can't do this anymore. There's no way that I can take a private value and make changes to it from outside the class. With the caveat that, yes, of course you can, but it's extremely convoluted and you can't do it by accident. You cannot make this choice by accident. It's some decision that you very consciously have to make. In practice, though, there's no way to make changes to this from the outside. It's a compile time error. Another issue that I have with C as a programming language here, and this is also not technically true, but it's true enough for what we know so far. This is a stack that I've implemented that can take integers, and that's it. That's the only thing I can put in this stack. If I want to make another kind of stack, like a string stack, I'd have to make a new interface. If I want to make a char stack, I'd have to make a new interface. If I want to make a float stack, I'd have to make a new interface. I'd have to go through this process of rebuilding and rebuilding and rebuilding and rebuilding and rebuilding. And in practice in C, this is literally what you would do. You go out into industry, you just keep building the same data structures over and over and over again because there's no library that has this stuff. But I'm digressing. You'd need to build a stack for every kind of value that you want to put into this thing. Object-oriented programming, this as a paradigm, can help solve this problem because we're starting to bundle behavior with the data itself. This push and pop function that I've got take this stack as input, but I can cast anything to a stack and I can pass it in. And I can cast anything to an int pointer and I can make changes to it internally. I'm not allowed, I'm just forbidden. The language doesn't give me the ability to make changes to the data that's contained within this named thing in an object-oriented language because we have those access modifiers on our data types. All right, so I'm gonna pause here for a second and just make sure we're okay. This is mostly 1020 stuff still. This is mostly 1020 stuff still, but I just want to make sure we're all okay on the same page. We're trucking along. I'll give you this C code so you can, I don't know, make fun of me for writing bad C, and then I don't really know. I don't really know why you'd want this. But I'm going to give it to you anyway. Okay. Let's switch gears a little bit. Yeah, I don't know about you, but I really don't like seeing that. It gives me like a little bit of discomfort. Like, why is somebody calling me? A message is information that is sent between two objects. Okay, so we've got these words class, we've got this word instance, we've got this word object. A message is information, so I'm very broadly saying information here, information that's being sent between two different objects. There's two names of objects that we have in this definition. We have an object that's called the sender, and we have the object that is called the receiver. So the sender is sending information, as its name implies. The receiver is receiving information, as its name implies, from the message that is being sent between the two objects that we have here. The receiver of the message, the object that is receiving the message, may make changes to its state based on the message that was sent to it. The receiver of the message may send something back to the sender. So we've got two objects, a sender or receiver. The sender is sending a message to the receiver. The receiver receives the message, may make changes to itself, and it may send something back to the sender to give it some additional information based upon what it did. In Java, this is methods. This is us calling methods on instances of classes. Formally, this is sending messages between objects. Here is some code. I'm going to give you a minute to read it. And I'm asking this question about this tiny fragment here. I'm going to unhighlight it so you can actually read it. But that is the fragment that I'm specifically asking about here. Who's the sender and who's the receiver? Oh, it's still changing. This is there, we'll do that. On this line of code, who is the sender and who is the receiver? This is really split, yeah. In this tiny fragment of code, me is the sender of this message. In this tiny fragment of code, you, my friend, you are all my friends, you are the receiver of this message that's being sent. So we've got objects that are sending messages to each other. We're calling methods in Java, but we've got objects that are sending messages to each other. The message is going to be defined by this object's interface. The interface, the method signature, is telling us what the name of the message is. So we've got two objects, a sender and a receiver. They are sending messages between each other. The name of the method that we're calling is the name of the message that we're passing between these two objects. That's the name of the message that we're passing. The values that we give, the values that we're sending, the information that we're sending to the receiver are the arguments that are listed in this function or method's signature. And the receiver is going to respond to us. The return type is what tells us how the receiver may respond to the sender. In Java, we can expand on this just a little bit by saying that a message can also tell us how things can go wrong. So we've got two objects, sender and receiver. We're sending messages between the two of them. The name of the message is the name of the method. The information that we're sending between the two are the arguments. The thing that the receiver is sending back to the sender is the return type. And we can also say, this is what's going to go wrong, maybe. And if something does go wrong, you deal with it.
So the message is just, I need your name, in that example?
Yes. Please tell me what your name is. Here's my name. Really formally here, the interface, all the interface says is what the objects can do. Taking this idea of messages and applying it to methods now, so the implementation of it, methods within a receiver should maybe make changes to the state that this class has, that this object has. Maybe delegate. So delegate is a word that says pass off to other things. So this class may have other classes embedded within it as attributes. We see this a lot in Java with the string type. The string is another kind of class. If this is an attribute that you have in here, you can ask for the string to tell you about its length, for example. So you can ask for the length of a string. We can delegate to other objects. We can send messages and call methods. It optionally decides what to send back to the receiver, because if the return type is void, it doesn't send anything back. It just kind of like sending something off into the ether, and it either worked or it didn't work. The interface says what the object will do. The method itself, the definition of the method itself, says how the object is going to do it. Okay, so I'm going to stop here because we've run out of time. Thanks, Michael. Thanks, Michael. Thank you, Michael. We've run out of time. What I want to do is just quickly summarize here. Yes, we have limited ourselves now to some of the same ideas that you've seen in Comp 1020, and you've reused these ideas in places like Comp 2140. But you should now be able to start using the terminology that I am using. When you're doing things like writing answers on tests, we will be assessing you on your ability to communicate using the language that we are using to describe these ideas to you. You should be able to use the same level of communication. We will do this part next week, although you should already be able to do this part. I hope that you all have a good weekend, and I'll see you on Tuesday. Bye, everyone.